Hello, everyone. Okay. Excellent. Right, so today we're going to talk about series, and as promised, the first problem is going to be on a geometric series. And so yeah. Probably the most important geometric series in your life. And okay. Which you encounter when you buy a house or an apartment. So let's have a look. Okay. Participants, chat. I need the chat. And so you should be able to see my screen. If you don't see my screen, please let me know. And a list of participants. Perfect. Okay. All right, some familiar faces, some less familiar people. Welcome everyone. Okay, so sequences and series part 2. Let's get to grips with a series. Take out a 400,000 mortgage, 3.6% per annum, with monthly repayment of X pounds for 30 years. Find X. Basically, find how much you will pay each month. Well, I mean, normal people do this. They go onto a website, mortgage calculator, and they say, okay, so price of the property is 400,000, deposit 0, okay, and your mortgage term is 30 years, interest rate is 3.6%, and it tells you that you will be paying 1,800 per month. Okay, so that's what this thing does. How does it work? How does it know? Let's try to figure out. Does anyone know how to do this? Does anyone do you know how to calculate the monthly repayment when knowing the initial parameters? 400,000 times, well, let's check. 400,000 times 1.036 to the power 30. Well, that's definitely not going to be 18,000. Right. It's not 18,000. I mean, I can tell you right now. I don't need to do any calculations. Perhaps you want to divide by 30? Or divide by 30 times 12. Divide by 30 and divide by 12. Okay, let's try that. Divided by where's division? Division by 30 and divide by 12. That's 400,000 times 1.036 to the power 30 divided by 30 divided by 12 is 50,000. It doesn't work. That's going to be 50,000. 50,945. So no. Archie, well, that we're doing the same thing. PI. What does PI stand for? Percentage in percentage. So yeah, doesn't work like this. So what is the problem with that? Well, because you're not. If you were to take 400,000 now and keep it for 30 years and then repay it. So if you take 400,000 now, keep it for 30 years, after 30 years, you will repay what's it, times 50 times 30 times 12. Whoa, that's a lot. So 18 million 340,447 pounds and 69 pence. Now, yeah, that's kind of a lot of money. Have I? Oh no. No, that doesn't make any sense. 400,000 times 1.036 to the power 30. It's 1 million. Okay, I'm mistaken. You want to pay or 1,155,720 and 07. Okay, this is how much you will need to pay at the end of your mortgage. Now, banks don't like that. They don't like giving you 400,000 and then you keeping it for 30 years because a lot can happen in 30 years. So they ask you to repay approximately, well, 1,000 or 2,000 pounds every month for 30 years, and then eventually you would repay. So you're borrowing money, but you're not borrowing the whole amount for 30 years. You're only borrowing you're only borrowing a certain amount for 30 years, then a smaller amount for 29 years and 11 months, etc. It's because they're only paying interest on the money you have left. Exactly. You don't pay interest on the money that you have already paid back. You don't. Very good. You don't pay interest on the money you already returned. Okay, so let's. So this is wrong. This is wrong. So let's. 50,000. That seems like. That seems unreasonable. So I did something wrong. Answer divided by 30 divided by 12. Okay, 3,210. Okay, that makes more sense. Sorry, 33. It's still not the correct value, yeah, because this implies that you do pay interest on the money that you have returned, but you don't. So the actual amount that you repay is going to be approximately 1,800. So let's see how they arrive to that number. So how does this happen? So we will draw like a table. I did this 2 weeks ago. So n is the number of months. Okay, then amount owed. Okay. So after 0 months, you have taken 400,000. That's a typical price for a house in the south of the UK. Unfortunately, it's huge. And to take out a mortgage like that, your family income has to be approximately £100,000, which is not good news because with each year it becomes harder and harder to buy a house. Okay, so after 0 months, you owe 400,000. After 1 month, first they will put interest on your money. So it's going to be 400,000 multiplied by the interest, but the interest per month. So 3% per year, and that means 0.3% per month. Yeah, because you divide by 12. So it's going to be 400,000 multiplied by 1.003, and then immediately you make a payment. So once interest has been added to your money, you make a payment. You make a payment of, well, X, because X is the size of your monthly payment. Does that make sense? So after 1 month, you owe 400,000 times 1.003 minus X. So the bank adds interest, and immediately you make a repayment of X pounds. So for example, if you were repaying, if, for instance, so you had 400,000, after 1 month, you would owe 400,000 multiplied by 1.03003. So you would owe 400,000, 1,200 pounds. That's your new. And you make a payment. Let's say you make a payment of X pounds. And that means, let's say X is, imagine X is 2,000. Minus 2,000. Minus 2,000. So you owe the bank 399,200. After 2 months, you got 399,200 multiplied by 1.003. So the bank calculates interest on the money that you still owe, and then you make a payment of 2,000. You make a payment after interest has been added, not before. So it's not that you do 399,200 minus 2,000 and then interest is added. It doesn't work like that because you've kept the money for a month. So they have to charge you interest because you've kept that money. And that would be times 1.003 minus 2,000. And it's going to be 398,397.6. So you can see that the amount of money you owe doesn't go down by 2,000. It goes down by, the first year, it goes down by 800. The second year, well, let me do a couple more years. So 4 years, it's going to be, so 0, 1, 2, 3. So 3 is going to be 397,592.80. 4 is going to be 396,785.571257. So the first month it goes down by 800, and then would it be easier if I did this? So 0, 1, 2, 3, 4, 5. So 400,000. So then here you get equals 400,000 multiplied by 1.003 minus 2,000. Okay. Yeah, that sounds right. And then equals this minus this. So the first month you go down by 800. Next month you go down by 800. I'm just going to increase that. First month you decrease the amount you owe by 800. Second month by 802, 804, 804. So because the amount you owe the bank goes down, that means the amount of interest you pay each month goes down. So that means the amount by which you increase goes up, if that makes sense. And let's see after how long it will take you. So 57 months, that's 5 years. You're still going down. All right, so if you pay, it will take you 306 months to repay. If you pay 2,000 every month, and you can see that towards the end, the amount, your debt goes down almost by 2,000 every month because you pay very little. The pattern is 800 times 1.003 to the power t. I'm not sure. Is it? 800 times 1.003. Oh, it does seem like it does seem. Ooh, thank you. Yeah, that's very observant. Yeah. Okay. But you understand. So this is the amount owed, and this is the reduction. Oh, actually, it makes perfect sense. This is a reduction of the amount owed. Okay, so I'm glad that we've established this. So after 0 months, you have 400,000. Then you increase the amount you owe by 0.3%, and then you subtract the x, which we don't know. We're looking for x. The second month is going to be 400,000 multiplied by 1.003 minus x, the whole thing, the whole amount that you owe, multiplied by 1.003, and then you pay x again. After 3 months, you take the whole thing. Well, you can simplify this. This is going to be 400,000 times 1.003 squared minus x times 1.003 minus x. As in 3. difference equations. Difference equations? I'm not sure what you mean by that. Then you, the third month, you multiply this again, multiply the whole thing by 1.003. You do 400,000 times 1.003 cubed minus x times 1.003 squared minus x times 1.003 minus x. Do you see a pattern? Is there, should I do another month? It's going to be 400,000. So every month you multiply by 1.003 and then minus x. You can, yes, we will do that. 1.003 to the power 4 minus x times 1.003 cubed minus x times 1.003 squared minus x times 1.003 minus x. So after n months, if you carry on, it's going to be 400,000 multiplied by 1.003 to the power n minus x, open bracket, yes, it's a common factor. It's 1.003 to the power n minus 1 plus 1.003 to the power n minus 2 plus etc. plus 1. Does everyone see that? Is there anyone who doesn't see how I got here? Yeah, sure. Okay, so after n months. And now we know that after 30 years, and 30 years is what, 360 months? After 360 months, the amount owed after 360 months, the amount owed is going to be 0. So we do 400,000 multiplied by 1.003 to the power n minus x multiplied by, I'm going to rewrite this as 1 plus 1.003 plus 1.003 squared plus etc. up to 1.003 to the power n minus 1. And that's going to be equal to 0. And you will notice that this is a geometric series with the common ratio 1.003, and the first term is a, is 1, and the number of terms is n. Yeah, because we start with 1. We start with 1.003 to the power 0 and end with 1.003 to the power n minus 1, so there are n terms. N terms. So we can write down the formula. Sn is equal to a multiplied by r to the power n minus 1 divided by r to the power n minus 1, r minus 1. So there's going to be 1 multiplied by r, which is 1.003 to the power n minus 1, divided by 1.003 minus 1, which is 1.003 to the power n minus 1, divided by 0.003. Okay, so we have 400,000, the initial amount, times 1.003 to the power n, minus x multiplied by 1.003 to the power n minus 1, divided by 0.003, and that has to be equal to 0. Okay, so from here we can rearrange. X is equal to 400,000 multiplied by 1.003 to the power n multiplied by 0.003 divided by 1.003 to the power n minus 1. And if we substitute that, because we know n is 360, so it's 400,000 times 1.003 to the power 360 times 0.003 divided by 1.003 to the power 360 minus 1, and that gives us 400,000 multiplied by 1.003 to the power 360 and times 0.003 divided by open bracket 1.003 to the power 360 minus 1. It's 1,818.58. Let's see. Ooh, very nice. Okay, so this is the method used. Well, it's not the method. Of course, it doesn't use this method. You can just derive a formula now. So the monthly payment that you will need to make for if you take a loan, not just a mortgage, any loan, is going to be what's that going to be? It's the amount the present amount, the amount you take out, multiplied by 1 plus the percentage rate. Well, the percent rate divided by 12 multiplied by n, where n is the number of years, to 12 times n multiplied by the interest rate divided by 12 times 100, 100 to the power, there's no power, divided by 1 plus interest rate divided by 12 multiplied by n multiplied by 100 to the power 12 multiplied by n minus 1. So this is kind of the formula, the general formula that you can use, where n is the number of years. It does look like something to do with E, of course, because if you have interest, if you have interest compounded continuously, Yeah, that's a very interesting one. Let's talk about this. So if you take, I mean, this is a bonky formula, but yeah, banks use it. It does converge to E. So imagine you take like £1,000 from the bank, at 100 100% per year. Now, if the money is compounded yearly, that means compounded once per year, you will need to pay 2,000, of course. Yeah, 2,000. If it's compounded twice per year, that means you will pay 1,000 multiplied by 1.5. Oh yeah, 1.5, because 50% to the power 2, because it's 50% twice per year. 50% twice. Yeah, so 1.5, you add 50% twice. Yes. If it's compounded 3 times per year, it would be 1,000 times 1.333 recurring to the power 3. So it's 33.3% thrice. Compounded n times per year. So it's going to be 1,000 multiplied by, so it's 1 plus 100% divided by 100 times n to the power of n. Right? Because if you think about it, this is, how did you get 50%? Well, 50%, you got, it's 1,000 multiplied by 1 plus 50% divided by 100. Well, it's 100% times 2 to the power 2. And this is 1,000 times 1 plus 100 divided by 100 times 3 to the power 3. And the same thing here. So if you simplify that, 100 cancels, so you get 1,000 times 1 plus 1 over n to the power n. And compounded infinity times per year, which is called continuously. It's the limit as n tends to infinity of 1,000 times 1 plus 1 over n to the power n. And we know by definition that this value tends to e. So it's 1,000 times e, which is going to be 2,701.821.828, 81828, 459045, etc., which is the number E. I did. You can check that they're correct. They're very easy to remember. How I remembered it. So 27 is easy to remember. Well, you can remember it as the 27th club. Not the best thing to remember, but neither is the rest. 1828 is the date when the famous Leo Tolstoy, who wrote War and Peace, probably one of the most famous Russian authors in the world. He was born in 1828, and then 1828 again. Then 45 is when the Second World War ended. 90 is double 45, and then 45 again. That's all I remember. Okay. And pi, I remember like 9 or 10 digits. It's not the most important thing in the world, but yeah, if the money is compounded monthly, basically, the more times it is compounded, the more you pay. But there is a limit. There's a limit to it, and if you check, that limit is going to be E. Okay. Let's talk about find the following limits. Well, we did this one. We did this one last time. Just to remind you, sine x can be approximated using the Taylor expansion as x minus x cubed over 6 plus x5 over 120 plus etc. And if we plug that in, it can be x minus x cubed over 6 plus x5 over 120 plus etc. So it's going to over x cancels, so it's going to be 1 minus x squared over 6 plus x4 over 120. And because x tends to 0, this all tends to 0, and it becomes, the answer is 1. Okay, so let's talk about this one. So cos x. We know that cos x is approximately 1 minus x squared over 2 plus x4 over 24 minus x6 over 6 factorial 720 plus etc. By the way, an interesting thing, if you remember, sine is an odd function, and it contains only odd powers of x. And cosine is an even function, and it only contains the even powers of x. That's quite kind of important. Right, now even powers of x, and only because it's an even function. This is true for any even function and any odd function as well, because tan also contains only odd. Tan is odd, and it only contains odd powers of x. E of x, we know that, sorry, I'm embarrassed, but I forgot That's what I forgot. I'm not 100% sure. Oh yes, 1 plus x. Yes, of course. Ex is 1 plus x squared over 2 plus x cubed over 6. Yes, Archie, that is trial and error. The odd evenness powers of f was determines the odd evenness of function, Grace. Well, no, because there is a strict definition of a function, but because x to an even power is an even function, it's kind of you can only have, if it's an even function, it can only be made up of even functions. And because we're dealing with powers of x, only the even powers of x are even. You will study the Fourier series, and the Fourier series is a trigonometric series. So it's, instead of x's, you have sines and cosines. And you will see that even functions are only made up of cosines, and odd functions are only made of sines. Okay, so let me demonstrate. So for example, if I have a function, y equals 1, if x is 0 x pi, can I do that? No, it doesn't like that. I do this. 1, 2, 3. No, it doesn't like that. Okay. Okay. And y equals -1. Or when pi less than x less than 2 pi. So imagine a function like this. It's a step. Well, it's a step function. So it goes like this, right? So 1 from minus pi to 0, and it's going to be -1, and it's going to be 1 from -2 pi, -pi, and finally it's going to be 1 from 2 pi to 3 pi. So you can see a function, right? So it's a stepwise function. It goes so it's like a square wave. Yeah, you can imagine that this is a square sine wave, square wave. Square. Square wave, and it's going to go like this. Now, can somebody tell me, is this function odd or even? It is odd, of course. It has a point of symmetry. It is odd. Let's find an approximation. And this function can be approximated with this function. Sine x. Okay. Not quite, but getting there. Plus 1/3 sine 3x plus 1/5 sine 5x plus 1/7 sine 7x plus 1/9 sine 9x. And as you can see, we're getting closer and closer and closer to plus 1/11 sine 11x. So this is called a Fourier series. And you can see as you get more and more terms, you get closer and closer to that stepwise function. And because it's an odd function, it only contains sines. Yeah, it does not contain cosines. And an even function would contain cosines. Okay. Right. So yeah, that's what to talk about. Okay, so e to the power x is this, plus etc. So e to the power minus x squared over 2, because x squared over 2 is 0 when x is 0. So we can substitute 1 plus minus x squared over 2 plus minus x squared over 2 squared divided by 2 plus minus x squared over 2 cubed divided by 6, etc. And if we simplify that, this is going to be 1 minus x squared over 2 plus x to the power 4 over 8 plus etc. I'm gonna skip the rest because I got a feeling that I won't need to go further. And then divide by x4. So here you go cos x. So it's going to be 1 minus x squared over 2 plus x to the power 4 over 24 minus, well, plus etc. Minus 1 plus x squared over 2 minus x to the power 4 over 8 plus etc. divided by x to the power 4. You can see 1 cancels, x squared cancels, and this doesn't cancel. So it's going to be x to the power 4 over 24. So that's going to be 3 minus 3 minus 3 over on 24. That's 1. That doesn't make sense. That's 3 on 24. 2 on 24, 1 over 12. So it's minus x to the power 4 on 12 over x to the power 4, which is minus 1/12. If a function is even, can we say that the derivative is odd? I think so. Rahul has asked if a function is even, the derivative must be odd. I can't imagine why not. Yeah, I don't think I can prove it right away, but it does seem like a valid conjecture. Yeah, but 0 is an even function. Okay. Number 3. Using the definition of the Taylor expansion, find the first term of the expansion 1 plus x to the power 1/2. Use the result to find the approximate value of square root of 1.2. Okay, so the definition of the Taylor expansion is that f of x is equal to f of, well, I should say Maclaurin Taylor expansion, where in the vicinity of x equals 0. In the vicinity or vicinity? Vicinity of x equals 0. Vicinity. Vicinity or vicinity. Vicinity, yeah, not vicinity. In the vicinity, yes, in the vicinity of x equals 0, of f0 plus f prime 0 over 1 factorial multiplied by x plus f double prime 0 over 2 factorial times x squared plus f triple 0 by 3 factorial times x cubed plus etc. Yes, I'm actually planning to do a slightly shorter session today, so maybe finish in 15 minutes roughly. Depends on how we go on with this question. So we have f of 0. We need these values. So f of 0 is going to be 1. F prime of 0, we differentiate, so it's going to be 1/2 multiplied by 1 plus x to the power minus 1/2. Is that it? 1/2 to the power 1 minus plus x. Yeah. Okay. Which is 1/2 times when x is 0 is going to be 1/2. F double prime of 0 is going to be 1/2 times minus 1/2 multiplied by 1 plus x to the power minus 3 over 2 equals, well, 1/2 times minus 1/2. We need the first 4 terms, right? So f0 is going to be 1/2 times minus 1/2 multiplied by minus 3 on 2, which is multiplied by 1 plus x to the power minus 5 over 2, which is, well, 1/2 times minus half. Stay there. I'm very sorry about that, about the assignments not published. I have checked, well, I have asked someone to publish them. I will double check. Sorry about that. I can send you a link to the assignments. So, apologies. Please check that the links work. If not, I will. Okay. So we found the we found these. So times -3/2. Okay. So we can double. We can now rewrite. So 1 plus x to the power 1/2 is equal to 1 plus 1/2 x plus, well, minus 1/4 x squared over 2, so 1/8, and plus so times x cubed. So that's going to be 3/8 over 6. 3/8 multiplied by 6 multiplied by x cubed. So that's 2, 3, 1, 16. So 1/16. Oh, interesting. I think I can see a. Can I see a pattern? Not really. No. Okay, so that's the first four coefficients, and we can use, so square root of 1.2 is equal to 1 plus 0.2 to the power 1/2, which is approximately equal to 1 plus 1/2 times 0.2 minus 1/8 multiplied by 0.2 squared plus 1/16. Because this is 3/8. 3/8 multiplied by 1, because 3 factorial is 6. So 3/8 times 6 times 1/6 is 1/16. 1/16 times 0.2 cubed, and that is equal to 1 plus 0.5 times 0.2 plus minus 0.2 squared divided by 8 plus 0.2 cubed, 0.2 cubed divided by 16. And this is 1.0955, and square root of 1.2 is approximately, root of 1.2 is 1.0954451115. So the error, the percentage error, is 1.0955 minus 1.09544515 divided by 1.09544515 times 100, of course, and that gives us, so 1.0955 minus answer divided by square root of 1.2 times 100, 0.005% error. So if you were ever asking yourself, how does the calculator know what square root of 1.2 is? Oh, that's how. The calculator doesn't know square root of 1.2, but it knows that the square root is a series, is a Taylor expansion. So it knows the Taylor expansion for 1 minus x. And this is how it works out the value. So all the calculator values are approximations. Raghav, sorry, just a second. So yeah. Well, it depends on the calculator. I mean, what kind of algorithm are you talking about? No, the binomial expansion gives you the same result. Like if you do the binomial expansion, it's the same. Is going to be the same. If you take the binomial expansion formula, because if you can realize here that if you have 1 plus x to the power n, 1 plus x to the power n, it's going to be, well, it's going to be 1 plus, this is going to be n, plus nx, plus n multiplied by n minus 1, x squared, over 2 factorial, plus n minus 1 multiplied by n minus 2 over 3 factorial, x cubed. And if you go binomial expansion formula, binomial expansion formula, here it is. This is the binomial expansion formula. We've just proved the binomial expansion formula in a different way. Yeah, this is the bottom one. Here it is. Archie, yes, you're probably right. I'm not claiming that Okay. The tail expansion is just one of the approximations you could use. There are many more. I am when I said the calculator does a Taylor expansion, not literally, it does some sort of expansion depending on the situation. I'm a well, I mean, I'm a practical physicist. I'm not a electronics guy, so I wouldn't know exactly what they use. Yeah, but yeah, thank you for pointing that out. They use some sort of expansion. It could be Taylor, could probably not Fourier, but some sort of expansion for an approximation. Okay, this first four terms of the same thing. It's the same problem. You can actually use the binomial expansion formula here. And actually, one of the questions in the assignment is to prove the binomial is to prove the binomial expansion. So it's maths 1205, and yeah, here it is, problem 11. You actually need to prove that formula using the definition of the Taylor series. Okay. What else do we have? Well, this is problem 21 from the assignment. Sine, cos, and using the sine, cos, and 1 plus x to the power minus 1. Well, here what you need to do is you need to realize that tan x is sine x over cos x, and sine x is x plus x minus x cubed over 3 factorial plus x5 over 5 factorial plus etc. divided by 1 plus 1 minus x squared over 2 factorial plus x to the power 4 over 4 factorial minus x6 over 6 factorial. And you can rewrite this as x minus x cubed over 3 factorial plus x5 over 5 factorial plus etc. multiplied by 1 plus minus x squared over 2 factorial minus plus x4 over 4 factorial minus x6 over 6 factorial plus etc. to the power minus 1. Do you see it? That this is 1 plus x to the power minus 1. Alright, so you can use this expansion. Yeah, usually 2 or 3 is good enough for an approximation. So yeah, well, I think they're asking for 5. Five powers. So yeah, you need the first. Well, you don't need 6, certainly. You can use 4. So you can drop this one. And yeah, do it like this. Where's the chat? Could please also add the links to mathematics examiner one I joined later. Google Classroom. Assignment 1. It's on the website. It's if you go to our website, you will find it. So, go to our website, assignments, And here they are. Assignment 1 and assignment 2 is here. And I've posted links for assignment 3, 5, and 6. 3, 4, 5, sorry. 6 is not published yet. All right, you're welcome. I think we'll finish here. And yeah, so enjoy completing the assignment. Enjoy the weekend. All right, see you. For problem 2, is the answer only valid if you take the first 3 terms of each and discount for the rest of the terms? Okay, yes, thank you for asking this. If you take more than 3, it will still work, of course. The answer will still be valid. However, if you take less than 3, you might end up with a wrong answer. You might end up with 0. Yeah, but more is always fine. Less usually not fine. Okay. All right. See you.